Good afternoon. I'm presenting the second presentation of slide for method of least squares. As we have discussed in the earlier slide, how can we apply method of least squares to find the normal equations for various curves? We have discussed the curve for straight line first, and we have found the normal equations for straight line by using this method. So in this PPT, we will first discuss the questions based on straight line. Then we will discuss the normal equations for exponential curve and how can we solve the questions related to it. So here we are discussing the first questions, how we can fit a straight line to the given data. This is the first question and this is the data given to us where x and y takes these values. X is taking values 0, 1, 2, 3, 4. Correspondingly, the values of y are mentioned. That is 1, 1.8, 3.3, 4.5 and 6.3. He's asking me to fit a straight line to the following data. So let us consider the equation of a straight line which we have assumed to be y equal to a plus bx. That means I need to find the values of the constants a and b so that I can find the best approximation to this curve for the following data. As we have discussed in the previous slide, we will not repeat that procedure again. You can remember the normal equations for your further assistance. As we have discussed, the normal equations for straight line are given by this. Summation of y is equal to na plus b summation of x, and another normal equation is summation of xy equal to a summation of x plus b summation of x square. I'm marking these equation number as 2 and 3. Now I need to find the value of summation y, summation x, summation xy, and summation x square from the given data. So here I have the data x, y, and x square. These is the values of x and y. Correspondingly, we can find x into y, that is 0, 1.8, 6.6, 13.5 and 25.2. And we can find x square as well, that is 0, 1, 4, 9 and 16. Now we will find all the values that we required for the given equation, that is summation of x. So summation of x will be 10. From here, we are getting summation x as 10 and summation of y as 16.9. Summation of xy as 47.1. And summation of x square as 30. So now we will substitute all these values in the two normal equations that we have written above. That is equation number 2 and 3. So I'm putting the values in these equations. So by equation number 2, we get this is summation y, n, that is the number of observations. There are 5 observations. So n will take the value 5, 5a plus b summation x, that is 10b. Let us mark it as equation number A, capital A. Now from equation number 3, which is summation of xy, that is 47.1, A summation x and b summation x square. So I'm getting these two equations. Now we have to solve these equations and we can get the value. We can multiply equation number A by 2 and we can subtract equation number A and B. So on solving these two equations, that is multiplying the equation number A by 2 and subtracting from B, that is we will get A as 0.72 and B as 1.33. We have got the values of both the constants from the normal equations we have found. Now, the equation of straight line required to fit the data will be given by 0.72 plus 1.33x. This is my best approximation to the given data. Like this, we can find the best approximations to the given data. Further, we have another question for fitting a straight line to the following data, where x and y are given by this. X is 1, 2, 3, 4, 5, and y is 14, 27, 40, 55, and 68. Again, we will assume the same thing. Let y, we will take the equation of straight line as y equal to a plus bx, and we will introduce the normal equations for straight line, which are considered as summation of y is equal to na plus b summation of x. Let us mark it as equation number 2. And another normal equation is summation of xy is equal to a summation of x plus b summation of x square. Let us mark it as equation number 3. So these are my two normal equations. Again, I need to find the value of summation y, summation x, summation xy, and summation x square from the following data. So we will solve the following data accordingly. So these are my values. Summation x, summation correspondingly y is over there for x, and then x into y. These are the values for x into y and x square. These are the values for x square. Now we will find all the corresponding terms that we need. That is summation x, 15, summation of y, 204, summation of xy, that is 748, and summation of x square, that is 55. These are my values. Now, let us put in the normal equations that we have discussed in the previous slide. Equation number 2 and 3. From equation number 2, we will get 204 is equal to, as there are 5 number of observations, so n will take the value 5, 5a plus b summation x, that is 15b. Let me mark it as equation number 1. Then another equation is summation of xy, that is 748, a summation x, that is 15a, plus b summation x square, that is 55b. This is my second equation. So on solving these two equations, we can solve by multiplying the first equation by 3. So we will get this, that is 612 equal to 15a plus 45b, and we can subtract both the equations. Second equation will remain as it is. Now on subtracting them, we will get the value of b as 13.6. Now substituting the value of b in either of the equation, that is equation number 1 or 2, we get the value of a. So if I substitute the value of b in equation number 1, that is 204 equal to 5a. So here we have 15b. So 15b. So here we will get a as 0. This comes to be 204 only. So here comes a as 0. So my first equation, that is equation of straight line, will be 13.68. This is the best approximation to the curve for straight line. Similarly, we can fit another type of curves also. As I told you, we will discuss about exponential curve also. So in the next slide, we will discuss how can we fit an exponential curve that is represented by y equal to a e to the power bx into a given set of values or into the given set of data. Again, we need the normal equations to fit this exponential curve in the given data. For that, let us consider the exponential equation, that is y equal to a e to the power bx. To find its normal equations, we have to remove bx from power of a e. That's why we have taken the log on both sides. So it will become log to the base 10 y equal to log to the base 10 a plus bx logs to the base 10 e. This we can represent it in the form of equation of straight line only, that is y equal to a plus bx, where capital Y will take the role of log to the base 10y. Capital A will be replaced by log to the base 10a. This is constant only, so we can replace it by a new constant, say capital A. Capital B will take the value b into log to the base 10e, and we can put capital X as x. You can keep small x as it is also. That means you can write it like this also. It hardly matters. It will not change the solution. For convenience, as we have taken all the constants in the capital form, that's why I have chosen small x as capital X. So we know that the equation of normal equations for straight line will be summation y na plus b summation x and summation xy a summation x plus b summation of x square. Now we will solve the question as we have done the previous one, that is for straight line as it is. Then in the end, we will replace the values of these capital Y, capital A, capital B to find the values of small y, a, b, and small b. Now we can put small a as anti-log. We can take the anti-log of a and small b as capital B by log to the base 10 e. And we can put the values in the given equation number 1. So let us consider a question to get the concept more clear, how we can use it to best fit the data. So this is the question. Use least square method to fit a curve of the form a e to the power bx to the following data. This is the data where x and y are given. We have 5 number of observations there. So first of all, as we have discussed, we need to form the normal equations for this exponential curve. Then we will find the best fit to the data. So as we have discussed in the previous slide, we can take log on both sides and we can represent it in the form of equation of straight line only. So I'm representing this curve y equal to a e to the power bx. I'm marking it as equation number 1. By taking log both sides, I'm representing in the form of capital Y equal to a plus bx, where capital Y will take the value log to the base 10y. Capital A will take the value log to the base 10a. Capital B will be b into log to the base 10e. And capital X will play the role of small x only. So we need to find the values from the given data. Accordingly, we need the value of all these value, that is we need to form the normal equations first. For this, that is summation of y will remain the same as we have done for the straight line, but just our constant representation is different now. This is the first normal equation and this is the second normal equation. Plus b summation of x square. So we need to find the values of summation y, summation xy, summation x, and summation of x square from the given data. So we will form the table accordingly, the constants we need. So here is the table. Capital X will play the role of small x only. This is the given value of small y. I am finding the value of capital Y first, which is log to the base 10y. So From the calculator, you can calculate these values. These are the values of log to the base 10 y. Now, capital of x square, which is same as small x square. So these are the values, and then capital X into capital Y. Take the product. These are the values of capital, x into y. Now, on solving, we get summation of x as 34, summation capital Y as 5.7536, summation of x square as 300, and summation of xy as 40.8862. So we will substitute these values in equation number 2 and 3. So by equation number 2, I will get this equation. And total number of observations are 5. So n will take the value 5. 5a plus 34b. Then summation xy, that is 40.8862. It will take the value a summation x, that is 34a plus 300b. This is my second equation. So we can solve it. Equation number equation number first and second by adding or subtracting the equations by multiplying by suitable terms. And on solving them, we will get capital A as 0.9766 and capital B as 0.02561. So now, as we have discussed, what is these are the values of capital A and B. As we have discussed, what is small a and small b? We want the values in terms of small a and small b. So small a will be found by taking antilog of capital A, and small b can be taken by solving this, that is capital B by log to the base 10 e. So small a will take the value antilog of capital A, that is 0.977.9766. On taking the antilog of this, we will get the value as 9.4754. And small b is taking the value b by log to the base 10 e. On solving it, we will get its value as 0.059. So these are the values of a and b. So my best fit for the curve that is given by equation number 1 is 9.4754 e to the power 0.059x. So this is my final curve which best suits the curve. We have another question, same on the same lines as we have done. Here we have 6 observations and correspondingly y are given. So again, my normal equation for this curve, that is y equal to a e to the power bx, will be capital Y is equal to a plus bx, where capital Y will take the value log to the base 10 y, capital A will take the value log to the base 10 a, and capital B will take the value b log to the base 10 e, and capital X will take the value as x only. So again, we have the normal equations for straight line, that is b summation x, mark it as equation number 2. Then second normal equation for straight line, mark it as equation number 3. Now on solving, 2, and 3. First of all, we need all the values that we can get from the table. So capital X is taking the value as similar as small x. This is my small y originally given to me. First of all, with the help of calculator, find the capital Y by taking log to the base 10y. Then capital X into y and x square. Now, the data will be summation of x will be 21. Summation of y, that is capital Y, will be 8.1753. Then summation xy, that is 36.6938. Then summation of x square will be 91. Put the values in equation number 2 and 3. That is 8.1753. Observations are 6 total, so n will take the value 6. Then second equation, 36.6938. This is A summation x, that is 21a, plus B summation y, x square, that is 91b. Now we need to solve the equation number 1 and 2. We can solve it by multiplying this equation by 7 and this equation by 2 and then subtracting them. On subtracting them, we will get capital B as 0.4617, and putting the value of B in either in equation 1 or 2, we will get capital A as minus 0.2534. These are the two values we have found for capital A and capital B. Now we can find the small a, that is antilog of capital A, which comes to be 0.5580. And capital B will take, small b will take the value b by log to the base 10e, which comes to be 1.0631. So we have found the value. So our best fit for the curve will be 0.5580 e to the power 1.0631. So this is how we can find the best fit for the exponential curve. In the next PPT, we will find some more other curves. How can we fit the data to that? Thank you.